Hello! Alright, so welcome back to school. Okay, so the purpose of this video, if you're wondering, is I'm going to show you how to solve an equation by taking square roots. Okay, some of you may be familiar with this from before, but we'll see. So let's say I gave you something like x squared equals 256. X squared equals 256. And our goal is we want to solve for x. So what we want to do if we want to solve for x, we see we have a square here. So in order to get rid of that square, we're going to take the square root of both sides. So if we take the square root of both sides here, the square root is going to cancel out with the square, and we're left with x equals the square root of 256. Now, what you could do is you could just plug in the square root of 256 into a calculator, and what you will see is that x is going to equal 16. And that's basically, if you're wondering, what your answer would be. Now, I want to also mention something else interesting about square roots, right? So another thing interesting about square roots, right? So we also mentioned, like, if in order to get 256, right? So 256 is the same thing as 16 squared. But also, 256 is the same thing as negative 16 squared, because the negative times negative will get you a positive. So what this implies actually is you're going to have two answers. So x is equal to negative 16 or positive 16. Or in other words, it's also written as x equals plus or minus 16. So something that looks like this. X equals plus or minus 16. Yeah. Or yeah, if you want to think of it, negative 16 and positive 16. Okay. Now, another thing I want to show you, this one is kind of interesting. So you might be thinking like, well, when was the last time I may have used a square root besides this Algebra 2 class? And some of you might be familiar with this thing called a right triangle. You guys, in the past, you guys may have solved problems with right triangles. Forgive my drawing. I know it's not the best. But let's say we wanted to solve something like this, and our goal is to solve for x, right? So if we wanted to solve for x in this case, right, what we would do is we apply this thing called the Pythagorean theorem. So if you guys remember the Pythagorean theorem, what you would do is you take the legs here, you square both legs. So this would be 6 squared plus 8 squared, so 6 squared plus 8 squared, and then this equals, and then x squared. Okay, and then what we would do is we can go ahead and simplify this. So 6 squared is 36, 8 squared is 64, and then what we want to do is we want to combine 36 and 64. 36 plus 64 is going to be 100, equals x squared. And then what we want to do is, in order to get rid of the square here, what we would do is we would take a square root. So when we take a square root here, the square root will cancel with the square root, and then what we have is usually we're going to get x equals 10, right? Because the square root of 100, if you put that in your calculator, is going to be 10. Now, usually what we do is we always take this positive result. Like if you actually did this, like square root of 100, right? It could be like negative 10 or positive 10, right? Because negative 10 squared is 100, and we have 10 squared equals 100. But the problem with this, right, if we look at this here, when we're considering lengths of a triangle, lengths can't be negative, right? So can't have a negative length. You would only have a positive length. So that's why in the past, if you've learned this in a different class, maybe Mr. Cam's class or Mr. Hashi's class or Mr. Sabato's class or your 8th grade teacher maybe. But what you would do is you would just disregard the negative length, right? And you'd only consider the positive one. So that's how you would usually get like x equals 10, right? So basically, just like that, x equals 10. You just disregard the negative 10. Yeah, so hopefully that sounds a little bit familiar to you guys. But yeah, just wanted to tell you that. Okay, next example that I have here. So let's take scenarios. So what if we didn't have to take the use the Pythagorean theorem on a right triangle? So like just something basic, like 3x squared equals 192. What would we do in this if we want to solve for x? So what I see is we want to get x squared by itself. So in order to get x squared by itself, I can see we can divide both sides by 3 here. 3's cancel. And then we get x squared equals, and we get 192 divided by 3. Do that on your calculator. X squared equals 64. Now, I'm hoping you guys know what the square root of 64 is, right? Because what you got to do is, in order to get rid of that square, we have to go ahead and take the square root. So the square cancels with the square root, and we get x equals, the square root of 64 is going to be plus or minus 8, right? So in other words, we're going to get x equals negative 8 or x equals positive 8. So yeah, if you're wondering, for the context of algebra 2, we want to consider both negative and positive solutions. So that might be a little bit different from what you remember in like algebra 1 or geometry. So we're going to consider both negative and positive solutions. Okay, I'm going to pause the video right here, and I will continue where we left off. Okay, bye. Hello. All right, so let's continue where we left off. Okay, so what I'm going to also introduce to you, and some of you may have learned this before as well. So it's like, well, what if you don't get nice numbers at the end? I'm going to introduce you to this thing called radical form. Hopefully some of you have learned it before. So I'm going to go ahead and clear the screen. Let's just take another real life example. Let's go ahead and take that triangle, right? That if we were to consider a right triangle, let's say both the legs are length of 5 and the hypotenuse is just, we don't know. We're trying to find the length of that hypotenuse, right? So what we would do, right, is in order to apply the Pythagorean theorem, we take one of the legs, square it, plus one of the other legs, and square it, and we set it equal to the hypotenuse squared. Okay, so what we want to do is we want to simplify this. So what I see is 5 squared is 25. 5 squared is 25 equals x squared. 25 plus 25 is 50 equals x squared. What we want to do is we want to get rid of the square. So if we want to get rid of the square, we're going to take the square root. So we're going to take the square root. The square cancels out with the square root. Okay, so next, what we would do, if some of you have learned about radical form before, what we would do is we need to break up this 50 somehow. So this 50, if you're wondering, we want to break it up into nice little factors. So I see 50 can break up into 25 and 2. And what we can do is we could, if we know the square root of 25 is 5, that's a good sign because we know 25 is going to break up into 5 and 5. So our goal is, when we're trying to create this factor tree, is we're trying to find two of the same number. Okay, so the way I've got this in the past, if you're wondering, might be different from what some of you may have heard, or some of you actually had me before. You guys might know this, but anyway, so what you would do is, so we're going to put all these numbers under this radical. So square root of 50 is the same thing. Actually, I'm going to rewrite this. I'm going to put the x on the other side. So this is x equals, and the square root of 50 is basically the same thing as 5 times 5 times 2. Right? 5 times 5 times 2. Okay, so what you could do in this sense, right, is you would you look for your partners in crime in jail. So here are your two partners in crime in jail. They look the same. So unfortunately, one will get shot. One comes out alive. So then you get x equals 5 square root 2. Yeah, so that is how you would do that. Now, what I had mentioned earlier is in algebra 2, usually you want to consider both like the positive and negative solutions. But usually in the context of the Pythagorean theorem, right, usually we're just considering x equals negative 5 square root 2 or x equals 5 square root 2. But what we would have is, since we're only considering positive lengths because we can't have a negative length for a triangle, we would usually just omit this, and then we take this result. So x equals 5 square root 2. And this is basically 5 times square root of 2, which is like 1.414 or something, if you actually really wanted to go ahead and do that. And this is approximately like 7.071. But what I would want you to do is you could just put it in radical form, as you can see there. Okay. Now, another way that you could do this, if you guys don't like this partners in crime example, like another way that you could do this is, like I said earlier, if you know the square root of 25 is 5, then you could just jump from this step down here. So this would just be x equals square root of 50, and then x equals the square root of 25 times square root of 2, right? Because 25 times 2 is going to be 50. If we know the square root of 25 is 5, this is just 5 square root 2, which is exactly what we have up there, if you're wondering. So a lot of different ways that you could go about doing it. It's all just a matter of preference, what you decide to do. Okay. All right, so I'm going to go ahead and clear the screen, and I'm going to show you another example. Okay, so let's say in this context, let's say we're not doing a real life example. We're not doing a real life example, and what we're doing is we're trying to solve for x. So we have x squared equals 192. Okay, so what we want to do again is we want to solve for x. So in order to solve for x, what we're going to do is we're going to take the square root. Take the square root of both sides here, square, cancel out with the square root, and then we get x equals the square root of 192. Okay, so now what we want to do is we need to break up that 192. So what I see as 192 is, if we make our factor tree, I see 192 breaks up into 64 and 3. And actually, what I see here is 64 is going to be a nice square root. So since 64 I know is going to be a nice square root, is 64 breaks up into 8 and 8, right? So essentially what you can do here is the square root of 192 is the same thing as the square root of 8 times 3. So like I said earlier, a couple ways that you could do it. You could, I could give you that scenario that I just gave you, right? You are with your partner in crime in jail, and you are trying to get out of jail. So what you're trying to do is, here's your partners in crime. One will get shot, one comes out alive. So you get x equals 8 square root 3. 8 square root 3. And again, what we want to consider is we both, in Algebra 2, like I mentioned earlier, whenever we take a square root of something, we're going to consider both the positive and the negative solutions. So since we consider both negative and positive solutions, this means x is going to equal negative 8 times square root of 3, or positive 8 square root of 3. Right, so these are your possible answers. So yeah, so that is how you would do something like that. Again, what I mentioned earlier is, if you guys don't like the way I showed you, you could also do it this way, right? So we know 64 and 3 makes 192, right? So what we have is, this is the same thing as x equals the square root of 64 times square root of 3. If you know that the square root of 64 is going to be 8, this is just x equals 8 square root 3. And that is exactly what we have there, if you're wondering. Okay? All right. Okay. I have a few more examples. I'm going to stop the video right here. Hello! All right, so let's finish this up. I only got 2 more examples left. All right, so I'm going to go ahead and clear the screen. Clear the screen. So let's say I gave you something like this. Let's say I gave you something like 2x squared equals 160. Okay, and our goal again is to solve for x. So what we want to do in order to solve for x, we want to isolate x squared by itself. So in order to isolate x squared by itself, we need to divide both sides by a certain number. What I can see is we're going to divide both sides by 2. Cancel the 2's here, we're going to get x squared equals 80. Next, what we want to do is we want to get rid of the square. So in order to get rid of this square, we are going to take a square root. Take a square root of both sides, square cancel out with the square root, and then we get x equals the square root of 80. Now what we have is, we want to break up 80 now. 80, I can see, breaks up into 16 and 5. And it looks like we got a little bit lucky here. We know square root of 16 is 4. So basically when we break this up, 16 breaks up into 4 and 4. So what we have is we have x equals, so the square root of 4 times 4 times 5. Okay, so what we have here is I can find, I see these are my two partners in crime and jail. These are my two partners in crime and jail. So what I have is, so one of them will get shot, one comes out alive. So you get x equals 4 square root 5. 4 square root 5. And then what we have is we want to consider both the positive and the negative solutions. So when we go ahead and write this out, this means x is equal to negative 4 times square root 5, or x equals 4 square root 5. So those are our two possible answers that could happen. Now, I can see that, I know this happened in the past. You could also break these 4s. You know, like, if you wanted to, you could break it up into 2 and 2, 2 and 2, and then you could get x equals square root of 2 times 2 times 2 times 2 times 5. You're going to have two pairs of partners in crimes in jail, right? You have one pair here, and then you have one pair here. So this would be x equals 2 times 2 times square root of 5, which would actually be, which would actually be the exact same thing if you like to do it that way. Or like I mentioned earlier, if you guys don't like the way that I've been presenting it, if you know that the square root of 16 is going to be 4, you could actually take this right here. So x equals square root of 16 times square root of 5. Right? Square root of 16 is going to be 4. And as you see, this is exactly what we have here. So a lot of different ways that you could go ahead and do this. However, your teacher in the past decided to teach it to you. But that is how you would do something like that. Okay? Right, I'm going to clear the screen and I'm going to show you one more example. Okay, last example here. Let's say I gave you something like 4x squared minus 5 equals 75. All right, so our goal again is we want to solve for x. So we want to solve for x. First I want to do is want to isolate just this entire term. So in order to just isolate that entire term, what we're going to do is going to add 5 to both sides. Add 5 to both sides here. We get 4x squared equals 80. Next, what I see is we want to get x squared by itself. Divide by 4 on both sides. 4 is cancel. X squared equals 20. Next, what I see is we have a square here. In order to get rid of it, I'm going to take a square root. Square cancel out with the square. We need to break up 20 because the square root of 20 is not a nice number. So let's go ahead and do that. So I see 20 can break up into 4 and 5. And what I see here is square root of 4 is going to be a nice number. Square root of 4 is 2. So what you could do here is this is going to be x equals, and the square root of 2 times 2 times 5, because 2 times 2 times 5 is 20. So what you would do in this case is look for your partners in crime and jail. Here are your partners in crime and jail. One gets shot, and then one comes out alive. So you get x equals 2 times the square root of 5. And again, what you want to do is you want to consider both the positive and the negative solutions. So this means x equals 2 square root 5, or x equals negative 2 square root 5. So those are your two possible solutions. Yep. So another way that you could do this, again, like I said, if you just don't like the way that I've been explaining it, what you could do is, just take these two numbers here. Take those two numbers here. Basically, this part just becomes x equals the square root of 4 times the square root of 5, and that's the same thing as 2 square root 5, which is exactly what we have there. So again, just all a matter of preference what you would do, what you decide to do. But basically, that's how you would go ahead and solve something like that. All right, and that is basically it for this video. Okay, let me know if you have any questions. Okay, bye.